Good morning. Thank you for taking the time to join us this morning. My name is Marty Loughlin, Vice President of Financial Services at Cambridge Semantics. We're a software company in Boston. And we have a very unique approach to the data lake we call the Smart Data Lake, and we're going to take a few minutes to talk about that. So I realize we're the last presentation before lunch, so we should probably keep this short, but really not that short. The point here is that what we really want to be able to do in the enterprise is enable our business users to have access to all of the enterprise data in a way that they can ask any question they want of that data without having to go back to the IT for more access or more capabilities. Ask any question of very complex data. And so we say any question, these are some examples of the kinds of questions that we're helping our customers answer. So it ranges from understanding, if you think back to the crisis of 2008 in financial services, what's my exposure to Lehman? That's a very complex problem to answer for large organizations, through questions like, what's the best investigator to use for a phase 2 clinical trial for an injectable liver drug anywhere in the world. So the characteristic of these questions is that they require the harmonization of data across many diverse and large data sets. And they also require us to be able to answer questions that we don't necessarily know in advance. So our approach to this is, as we think about the enterprise landscape today, we think of it as a puzzle. Your data is residing in many disparate databases, many disparate sources, and it's pretty difficult to ask questions that span those data sources. We can bring a couple together, we can bring maybe 3 together in the current BI tools, but to go beyond that is very challenging. And at Cambridge Semantics, what we're doing is helping you bring all of your enterprise data together with a common harmonized meaning and a way to access all of that data without having to worry about data integration. So as a business user, I can now view the data in many different ways, ask different questions that span many parts of that data without having to worry about where that data came from or how to join it together. Of course, the beauty of this is if you think about any puzzle, you don't know what the pieces are missing until you get to the end of the puzzle. The same applies when you apply a model to your data and bring it all together. You can suddenly identify where the gaps are and use that as a way to tap into new data sources to fill in the picture. So how do we do this? So our platform is based on semantic web technology. We use models to describe data, high-level business conceptual models, and we build those across all kinds of data sources. So for example, if you think about a traditional relational data source that has rows and columns, we can represent that as a graph, as an entity and its relationships and properties. We can do this for unstructured data too. So we have natural language processing capabilities that identify entities and concepts and sentiments in text, and we can extend the graph with anything that we extract from those sources. This also applies to other kinds of data sources, enterprise systems that may have structured and unstructured data. We can extend the graph with data extracted from those systems also. And so what we're doing is building a representation of the data that's expressed in high-level business conceptual terms, that spans all of the different data sources that were brought together, but isn't tied to the physical representation of any of them. We can extend this model easily, and we can now ask questions that span many hops in the model. So we can ask a question about a company's market cap and how that relates to safety signals that may be captured in a note. Think about doing that in a relational world that requires joins across many complex data sets. You can do it, but it requires sophisticated programmers and developers to do that. Our tools allow you to build queries using a visual query builder to access this kind of data. So the model that we use, this is an example from the pharma and life science space, that model that we use to harmonize those different data sources is also the model that we use to provide users access to the data. So you can build dashboards, visualization, search, analytics, filtering, all driven by the model. These dashboards are graph aware. And this is the power of being able to ask questions that you didn't necessarily know in advance. You can infer relationships, you can construct new data through these dashboards and build views that, as I said, answer questions that were not anticipated in advance. So how do we do that? We have a very scalable platform. We've been developing it since 2007. The team that started the company came out of IBM. We're working on semantic web technology there, building a tool set that allows us to do all of what I've described end to end without writing any code. So this is business analyst and business user capabilities. And we can do it at scale. And we do that through a couple of different approaches. So in this picture, this is our sort of end-to-end architecture. The middle layer is the storage layer. We sit on top of almost any kind of storage platform. So we leverage Hadoop HDFS. We sit on top of Amazon's S3 storage. We sit on top of Google's cloud platform. We're independent of the storage itself. And our tools on the bottom layer, this data lake server, allows you to prepare data for storage in the lake. We have tools that catalog data sources, capture configurable metadata, and assist the business analyst mapping those sources onto the common semantic model. We do that for structured and unstructured data. We ship with natural language processing and text analytics capabilities. But more importantly, we have a framework that you can plug in third-party tools. So if you're using Lingvamatics or Lexalytics or any one of other 40 products to do work on unstructured content, we can take the output of that and harmonize it with the graph so that you can do analytics across combined structured and unstructured content. Once you have the data in the lake, there are ways for end users on the top layer to browse the available data sets. We call this smart data discovery. Browse the available data sets in the lake, select the ones that they're interested in, and then load them into memory. And this is really the secret sauce in terms of our ability to scale this platform. If you know anything about semantic web technology, it's been around a long time, it's very powerful, but it has a performance overhead in terms of being able to do interactive queries. We've solved that problem with this technology. So the Graph Query Engine is a massively parallel, in-memory, semantic data standard compliant graph database. We have it running on 200 nodes on Google's cloud platform at the moment, and we're about to complete a 1 trillion triple benchmark, and we're going to blow the socks off the last one. So what that enables us to do is do interactive query and analytics, all of the things that our dashboards support at very large scale. So when you think about the smart data lake and why would you leverage a platform like this, we think along two dimensions. One is the number of data sources from few to many, and the other is the number of data sets from few to many, or from small to large, I'm sorry. And so we can handle simple data, we can handle small data sets, we can handle big data sets that are simple in structure, but that's not really our sweet spot. Our sweet spot is really when you've got multiple data sources, very diverse data of different entity types where you want to ask questions that span across those entities and data sets. And we can do that for complex data at very large scale. If you're interested in learning a little bit more about what we do, you want to see a demo of either the data ingestion and smart data lake server component of the platform, or all the way through to use cases that we've applied this technology to in financial services and life science. We're at booth 564, and we'd welcome you over for a demo. Thank you for your attention.